the strongest magnet in the universe has been discovered. It's an exotic, ultra-rare neutron star. It's called GRO J1008-57, and it's got a magnetic field over 1 trillion times stronger than the Earth's. Stars like this are so strong that they have the power to do ridiculous things to anything that comes even remotely close. If you got within 1,000 kilometers of it, you'd simply dissolve. Your atoms would be super stretched. Their shape would warp into something completely unrecognizable. The molecular structure that makes you up? Forget about it. It's gone. You just disappear. So nothing good can come from messing with a star like this. But how magnetic is it? Hi, I am Haroon, and you are watching the Tech Look. Well, its field is calculated to be 1 billion Tesla. Tesla is the unit we use to measure how magnetic something is. Just to put this into context, the Earth's magnetic field is 1 millionth of a Tesla. But we've cooked up something far stronger in the lab. This is what 1200 Tesla did. Despite its supercharged magnetic strength, the star is actually incredibly small. It has a diameter of 20 kilometers. You might be wondering just what makes a star like this so magnetic? First, we need to find out more about how these neutron stars and their rarer subtypes come about. Neutron stars are created by the death of massive stars. Having run out of fuel, their upper layers are obliterated and the core collapses. We witness an extreme explosion, a supernova. Leftover electrons and protons come together to form neutrons, and with the right solar mass, we end up with a neutron star. A severely squashed down version of what was there before. Before going further, I want to share that we provide graphic designing, video editing, and other digital services, so contact us on codemelding.com, if you are interested. The link is given in the description. After opening the website, you will find a WhatsApp button you can contact on WhatsApp. Okay, now let's get back to the video. Astronomically speaking, they're the densest thing out there. If you dropped a marshmallow onto a neutron star, it would have the energy of an atomic bomb because the gravity is so powerful. So they're cosmically very small, but unbelievably dense. Let's put it another way. If I had a matchbox full of neutron star material, it would weigh approximately 3 billion tons. Or let's go another way. Maybe something smaller like a sugar cube. A sugar cube of neutron star stuff would weigh as much as a mountain, and I'd be very strong. But what stuff makes up neutron stars? Why are they so dense? Well, their insides are a bit of a mystery. We know that they have atmospheres made up of hydrogen and helium, and an outer and inner core made from neutrons, electrons, and atomic nuclei. But we still don't know what hyperdense matter lies at their center. So does this density cause a star's megamagnetism? Actually, we don't know. This takes us literally to the edge of scientific thinking. Scientists believe that as a neutron star is born, the magnetic field of the previous star shrinks. Combine this with this unusual, highly dense matter, and this could cause the phenomenal magnetism it wields. So we don't really know why a neutron star is so magnetic. It's a total mystery. But the neutron star's density is just the tip of the iceberg. They are capable of far stranger things. We observe binary systems of 2 neutron stars that are in orbit around each other. And when we observe these systems, we see them getting closer and closer together all the time. So what will happen eventually is that they're going to collide. And when they merge, the neutron stars will be completely destroyed and form a black hole. So when 2 neutron stars fuse together, colliding violently, this can create black holes. But this can also give birth to things called magnetars. And that's what is believed to have happened with our strongest magnet. However, there's another reason it's one of the rarest stars in existence. Not only was it once a magnetar, it's now what's known as an X-ray pulsar. This pulsar is truly incredible. It exists in a binary system with another star orbiting each other. But it's not an equal relationship. The highly magnetic pulsar feeds off its lower density companion, with energy accumulating at its magnetic poles. It gives off bursts of X-ray pulses, like a lighthouse in the deep, dark corner of the universe. Dame Jocelyn Bell Burnell discovered them in 1967 and wrote the rule book for how we monitor these phenomena. The pulses are short and quite steep, so these things have to be small. The other thing that we very quickly established was that the post period was very, very constant. It wasn't getting tired, which means it's got large reserves of energy, which means it's big. So it's small, but it's big. So you have to be more precise in what you're saying. It's small in width, it's big in mass. So high density, so high density.